Alright, this is 6.1, Lesson 2, Simplifying a Rational. So, first off, I'm going to simplify a standard fraction. Alright, this is something you've seen a million times, but I want to do it in a very specific way that we're going to be matching when we're doing this with rational expressions with polynomials. So, first things first, I'm going to prime factor, I'm going to rip apart each of my pieces. So I have 18 over 24, which I can rip up to be 2 times 3 times 3, and I can rip up 24 to be 2 times 2 times 2 times 3. If you have issues doing any of the prime factoring, just make a factor tree out of this. Alright, so now that it's broken up, what I'm going to do is just cancel things out. That's kind of the only fun part about rational equations. So you get to take your pen, your red pen, and cancel things out. Do I have a 2 on top and a 2 on the bottom? Well, then it goes away. I have a 3 on top. Does I have a 3 on the bottom to go with it? Yep. Alright, and once you do that, whatever is left is your reduced or your simplified fraction. So in this case, it's 3 over 4. Alright, now let's do the same thing except this time with the polynomial. So I want to factor something which, when multiplied, is x squared plus 3x minus 4. In other words, I'm going to get binomial, and it's going to be x plus 4, x minus 1. Again, see previous chapter if you're having any difficulties with factoring. I'm just doing this quickly in my head, but I could always use the AC method. Let's see, on the bottom I have x squared minus x minus 20. I think it's going to be 4 and 5, specifically negative 5, so that I get that negative x in the middle. Okay, so now that I've factored the top and the bottom, is there anything that matches? There is. Cancel it out. So here's an x plus 4 on top and an x plus 4 on the bottom. So just like we did before, I would write it out as my simplified form. So I just canceled out the x plus 4 on top and the x plus 4 on the bottom. Now, something to take note of, when we're doing rational equations later on, you still have lost negative 4 as being part of the domain. See the previous video. Even though you canceled it out, you can never cancel out something that's been removed from the domain, and you have to match its starting conditions. Alright, now the last example for lesson 2 is kind of a weird one. So over on the side here, let me ask you a question. If you have $100 and you spend 1, what do you have left? Yeah, positive 99. Now what if you only have $1 in your bank account and a $100 debit comes out? What are you left with? Negative 99. Wait a second, did I just change the order of the 1 and the 100 and it made it negative? So yeah, it turns out that, and this works for any number, if I have 7 minus 2, which equals 5, if I do 2 minus 7, right, so I switch the numbers, I end up with negative 5. Right, subtraction is not commutative, so when I change the order of it, I don't get the same thing, like addition would. But what I do get is the opposite. Now we can use this to our advantage, and do you see the 2 minus 7 equals negative 5? If I multiplied both sides by negative 1, right, what I end up with is negative 2 minus 7 is equal to 5. Negative and negative. But wait a second. Essentially what I've just said is negative 2 minus 7 is equal to 7 minus 2. Do you see that between the left side and the right side? I've changed the order, and I ended up with that negative on the outside. So when I look at my third example, 7 minus y over y minus 7, they look the same except their order is wrong. So what I'm going to do is change the order. And when I change the order, I'm going to do like I did over here and pop out a negative. I'm going to factor out a negative. So this becomes, when I factor it, negative y minus 7 over y minus 7. And now I have two y minus 7s. They cancel, and I'm left with negative 1 over 1, or just negative 1. Alright, this trick is going to creep up a lot on the problems, and it just happens.